Hey guys, it's Mr. Gilbert coming to you with your first lecture on electricity. First of all, defining static electricity. So we're going to look at static electricity and then we're going to look at currents as well. So static electricity is defined as the accumulation of excess electric charge on an object. The accumulation of excess electric charge on an object. That's static electricity. So similar to other fields, in electricity, there's a law of conservation of charge. So the law of conservation of energy, things like that. It's always, there's nothing created or destroyed. It's always the amount we originally had. So the same is true here. Law of conservation of charge. Charge can be transferred from object to object, but not created nor destroyed. So the amount of charges there are in the universe is constant. They can go from here to there. And so when you touch a doorknob in the winter, you shock your finger, or you see a lightning strike, or you plug in your phone to a charger, charges are moving from point A to point B, but they're never being created or destroyed. All right. So it's a law of conservation of charge. Charge can be transferred from object to object, but not created nor destroyed. So charges exert force on each other. So opposites attract and like charges repel. So for instance, let me pull out my brush here. So if I have a positive charge and a negative charge, they are attracted to each other. Now these lines I'm drawing are called electric field lines. Electric field lines go out from the positive and into the negative. And so opposite charges will attract. And so we draw the electric field lines and those would come together. All right. If I have two positives, they will move apart from each other. Like that. And then likewise, the same would be with two negatives would move apart. So like charges will repel and opposite charges will attract. All right, pretty simple. So that's an electric field. This area here, that's called the electric field. An electric field is the area surrounding every electric charge where force is exerted on other electric charges. So it's basically where the charges are close enough to impact each other. That's an electric field. All right, so it doesn't matter if they're opposites or like charges. If there's an area where they're going to interact, that is called the electric field. And what we've drawn here are the electric field lines. So some materials, and this should be a review from middle school, even elementary school maybe, but some materials allow the movement of charges easily and some do not. And so a conductor is a material in which electrons are able to move easily. Examples would be most metals allow electrons to move easily. Think of copper wire. Right, so those are conductors, and then insulators are materials in which electrons are not able to move easily. Right, examples would be plastic, wood, rubber, glass. Those are all examples of insulators. Now, so about charging. There are four types of charging we'll look at. So charging, so most of us think of charging my phone or charging my laptop or whatever the case may be. Charging is defined as the transfer of electrons between two objects near one another. So the transfer of electrons between two objects near one another. So if I bring the two objects in close to each other and electrons are able to move from one place to the other, that is called charging. So there are four types of charging. We have charging by contact. That's the process of transferring charge by touching or rubbing. All right, so when two things, so if you've seen rub a balloon on your head, that would be charging by contact. So when two things are actually touching and they transfer electrons. The second one is called charging by induction. That is a rearrangement of electrons on a neutral object caused by a nearby charged object. All right, that is a rearrangement of electrons on a neutral object caused by a nearby charged object. And there's a famous thing that you can look up, and I'll try to remember to include this in the guided notes, but a YouTube video. There's a famous statue in Cincinnati. I think it's technically Monroe or Lebanon maybe. That is called Butter Jesus or Touchdown Jesus that caught on fire a few years back. And he's called Touchdown Jesus because he had his arms up in the air like a referee signaling a touchdown or an extra point. So everybody called him Touchdown Jesus. It was called Butter Jesus because he looked like he was carved out of butter. But that statue caught on fire. It was struck by lightning. So I'm gonna show you kind of what happens. So if you will, this statue of Jesus, and he had his hands sticking up in the air. There's Jesus, sweet beard and everything. This ginormous statue of Jesus stuck up in the air off the ground. There's a big lake in front of him. The church is called Solid Rock Church. Some of you have probably seen it before. But there's a big Butter Jesus or Touchdown Jesus statue sticking up in the air. Now the statue was white on the outside. It had some sort of like plaster covering. But the inside was actually a metal frame, which is a conductor, right? And so what happened is that a cloud came over top. Now, the earth is positively charged. Keep that in mind. The earth is positively charged. So anything on the earth that's contacting the earth is going to be generally positive. All right, so Jesus is touching the earth, so he's positive. Well, the cloud is full of both positives and negatives. Both. It's got positives and negatives. But what happens over time is that the cloud lowers, the cloud drops or moves in, gets closer to the earth. And what happens is that same cloud realigns. All the negatives go to the bottom because, remember, opposites attract. So the negatives go to the bottom and the positives go to the top. So it realigns. So this cloud drops down and everything realigns. And what happens, so that is charging by induction, the rearrangement of electrons on a neutral object. So the cloud was neutral or is neutral, but the charges have been realigned. So charging by induction, the rearrangement of electrons on a neutral object caused by a nearby charged object. So Jesus is positive. The cloud is neutral, but once the cloud gets close enough, it charges by induction, meaning all the charges line up a certain way. The next one is static discharge. That is the transfer of charges between two objects because buildup of static electricity. So the static electricity, that's just the buildup of charges. They're going to discharge. So static discharge, transfer of charge between two objects because of buildup. And so what's going to happen is these electrons are finally going to give up and they're going to strike Butter Jesus. Now, my colorblind self trying to make some lightning here. I don't know if those are the right colors. But what happens is, what happened historically, if you can go watch the video, Butter Jesus catches on fire and burns up, and there's no more Butter Jesus because of that. They have since rebuilt the statue and changed how it was made. But that is static discharge. So this buildup of charges, this is called induction. And this lightning strike here is called static discharge. So we've gone over 3 so far. We've gone over charging by contact. We've gone over charging by induction. We've gone over static discharge. And then the 4th type of charging is grounding, connecting an object to earth to prevent unwanted static discharge to another object. This is, if you will, what we do when we use that 3rd prong on our plugs. That's a grounding, all right? Or even to the extreme, if you see a lightning rod on a tall skyscraper, that's for grounding. Now, if you have a newer home in Independence, this is actually code. This is required for your home. So in your basement, probably in like a concrete storage room in the corner of your basement, you'll see a piece of rebar sticking out of the ground. It'll go into your concrete and it'll have wire connected to it. And what that is a grounding. And what that does is so that instead of frying Butter Jesus, all this stuff is flammable, it creates a path of least resistance. And so basically it's a place where if you were to take a pole my colorblind self doing this, but had they found a way to connect some type of lightning rod, if you will, next to Butter Jesus, the lightning would have gone through that lightning rod into the ground and never would have touched the statue. So when we put a lightning rod on top of a giant skyscraper or a little one inside your basement, the goal is for that giant static discharge to be grounded, to go straight to the earth and never touch the rest of your stuff. All right, and so that's grounding. So 4 types of charging we talked about: charging by contact, charging by induction, static discharge, and grounding. And so the last thing we're going to talk about is electric current. And this is going to be the emphasis of the next lecture, but electric current is the net movement of electric charges in a single direction. If you will, it's controlling the flow of the charges. So think about the current that runs through your house, in the whole thing, or just your Christmas lights, or whatever. That's a current. It's a controlled flow of electrons. The net movement of electric charges in a single direction, that's electric current. That is measured in amperes. It's measured in amperes. And to give you an idea, you don't need to know this number in detail, but I'm going to tell it to you. 1 amp, so 1 ampere, is equivalent to 6,250 million billion electrons flowing. So electrons are so small, it takes so many to make something happen. All right, so don't think that's like 1 electron going through. 1 amp is 6,250 million billion electrons flowing. That's a lot of electrons. All right. I do have one last thing I do want to cover with you, is voltage. Voltage difference. Voltage or voltage difference. That is the place where electric charge flows due to difference in electrical charges. A voltage difference is the place where electric charge flows due to difference in electrical charges. And that's measured in volts. Very creative, I know. But the interesting thing here that I want you to consider about volts is basically how likely something is to move, or how much those charges can move. So I want you to think of it this way. If I have 2 charges that are opposite, if you can see my hands here, if I have 2 charges that are opposite, they're going to attract. And so, boom, they rush together. All right, but if they're here, maybe they're still close enough to attract. There are electric fields. That electric field exists, and so they get to smash harder. All right, so they're still attracted, and they're going to slowly move forward and boom, speed up, smash into each other. But if they're far enough apart, they're not going to attract. That force isn't strong enough for them to attract. All right, same is true if they're the same. So if I have 2 negatives, they're going to repel. All right, they're really close, going to push away hard, but if they're barely able to contact each other at all, they're barely going to push away. And so voltage difference, I'm going to give you that definition one more time, is the place where electric charge flows due to difference in electrical charges. So it's basically like how much potential is there for there to be moving of electrons across something. All right. So that's it for the introduction. If any of that doesn't make sense, feel free to ask questions, but I think some of it will make more sense as we get into both circuits, how we control a current, and the calculations for currents and voltage. So, all right, thank you.